envisioning yourself on a glacier and seeing something come out of the melted ice. It wasn't a rock or a fossil. It was the face of a creature that lived tens of thousands of years ago. When the world's permafrost and ice sheets started to melt a few decades ago, scientists found animals that were so well preserved, it looks like they could breathe again at any time. They found mammoths with blood still flowing through their veins, rhinos with fur and organs still intact, lions frozen in the middle of a hunt, and bears curled up as if they were still dreaming during the Ice Age. The animals that are no longer alive that we found frozen in glaciers are proof of a lost world where life and death met under the snow and time stopped. The Yuka mammoth, the ice-cold giant with blood still flowing. In 2010, reindeer hunters in northern Siberia found a piece of tooth sticking out of the frozen ground. They didn't know they had found one of the best preserved mammoths ever. They later named what they found Yuka. She was a young female woolly mammoth, probably 6 to 8 years old, and had been lying in the permafrost for about 39,000 years, with her body mostly still together, her fur still soft, and her blood still dark red. Ice Age tissue that seemed to bring life back to extinction was held by scientists for the first time in history. Yuka was found near the Laptov Sea in Yakutia, in a layer of frozen silt that had sealed her body like a vault. When researchers from the Mammoth Museum of Yakutsk began excavating her, they noticed something extraordinary. Her trunk and legs were preserved down to the skin, with visible muscle and fat, but it was when they thawed the surrounding ice in a controlled chamber that the discovery turned historic. Dark, viscous liquid began to drip from her wounds. It wasn't melted ice, it was blood. Samples were immediately collected under freezing conditions to avoid contamination. Later tests at the Northeastern Federal University confirmed that the liquid contained hemoglobin proteins and other blood components still identifiable under a microscope. While it wasn't functional blood anymore, the preservation was so exceptional that the researchers could study the structure of mammoth red blood cells for the first time. The fact that the liquid remained unfrozen at sub-zero temperatures suggested the presence of natural cryoprotectants, chemical compounds that kept it from turning solid, similar to the antifreeze proteins used by Arctic fish today. Yuka's soft tissue revealed even more. Her muscles retained their reddish-brown color, her internal organs were still distinguishable, and her fur, strawberry blonde in places, was nearly complete. Carbon dating placed her age at around 39,000 years, but the environmental conditions had kept her in a kind of biological pause. When scientists measured her isotopes, they could determine what she ate, mostly steppe grasses, sedges, and wildflowers. In her stomach were partially digested plants, proof she died suddenly, probably within hours of feeding. Another question was what caused the death. She had deep cuts and tears on her skin and bones that looked like they were made by the tusks or claws of a big animal, maybe an Ice Age cat or a person. She may have been killed or scavenged, and then she was dragged into a pit that later filled with freezing water and silt, covering her in ice right away. The way her limbs are arranged supports this idea. It suggests that she wasn't buried in a random way, but slowly, maybe by a slow flood that turned solid soon after. Unlike earlier mammoth finds, Yuka's preservation allowed full 3D scanning and digital reconstruction. Her brain cavity was intact, and researchers even recovered pieces of the dura mater, the membrane that protects the brain. This gave insight into Ice Age mammal neurology, something almost never preserved. The scans also revealed fat deposits under the skin, confirming how mammoths stored insulation for Arctic temperatures. Her DNA, extracted from bone marrow and hair, showed relatively little degradation, making Yuka one of the most valuable genetic specimens ever discovered. In 2019, South Korean and Russian scientists took Yuka's preserved tissue to the next level. They isolated cell nuclei and attempted to activate them by inserting them into mouse egg cells. To the astonishment of many, some of the mammoth nuclei showed brief electrical activity, a sign of partial biological response. The cells didn't divide, but the experiment proved that fragments of life processes could still flicker within 39,000-year-old remains. It reignited global debate about cloning and de-extinction, with Yuka at the centre of it. Her fur also revealed secrets of adaptation. Under infrared analysis, researchers found she had 2 layers of insulation, long guard hairs up to 50 centimetres, and a dense undercoat that trapped air like modern polar bear fur. Chemical residue inside the hair shafts contained carotenoids, natural pigments that may have protected her skin from ultraviolet radiation reflected off snow. In essence, her body was engineered by evolution to survive the harshest cold ever known. Even her hooves told a story. They were wide and flat, and they were made with tough keratin layers so she could walk on snow and mud. Wear marks on her body showed she moved over a large part of the Siberian steppe, possibly moving with her herd. Even though she was strong, she spent her last moments alone, in the cold and silence. The steppe bison Blue Babe of Alaska. In 1979, gold miners near Fairbanks, Alaska, were breaking through frozen ground with heavy equipment when it hit something that wasn't rock or ice. The body of a huge Ice Age bison was preserved and buried deep in the permafrost. The skin was as tough as leather. The muscles were still there, and the fur was a deep, strange shade of blue. They found one of the best preserved Pleistocene animals that had ever been found. In the end, scientists named it Blue Babe, after the mythical American big blue ox, and because, amazingly, this 36,000-year-old bison was blue. When paleontologists from the University of Alaska Fairbanks arrived, they realized the miners had uncovered something almost unheard of. Not bones or fragments, but a near-whole body. Its front half had been sheared away by mining equipment, but the rest remained locked in ice. When it was carefully thawed, researchers saw a thick pelt of reddish-brown fur still clinging to skin that had turned bluish-grey. The unusual colour wasn't just the result of age. It came from blue iron phosphate minerals that had formed when the animal's body reacted chemically with permafrost minerals over thousands of years. The process had literally dyed the flesh a deep blue tone, creating a natural preservation miracle. Blue Babe belonged to the species Bison priscus, or steppe bison, a huge Ice Age grazer that once roamed from Europe across Siberia and into North America. These animals were larger and more muscular than modern bison, with massive shoulder humps and sweeping horns. They thrived in the cold, grassy tundra known as the Mammoth steppe, feeding on sedges and herbs that covered the northern plains. Blue Babe's discovery gave scientists their first look at what such a creature truly looked like in life, not just from bones, but from skin, hair, and even muscle tissue. As researchers carefully examined the body, they noticed something even more extraordinary: scratch marks and punctures across the rear haunches and back. The wounds were consistent with the claws and teeth of an Ice Age lion, Panthera spelaea, one of the top predators of the Pleistocene. It appeared that Blue Babe had been hunted, likely attacked, by a pride that targeted the bison's hindquarters. The lions may have fed briefly before a sudden Arctic cold snap froze the carcass solid, halting decay almost instantly. In the blink of an Ice Age night, predator and prey were separated forever by ice. When scientists from Fairbanks Geophysical Institute began to thaw Blue Babe for study, they used an unusual method: hairdryers and warm water. The process took months as they melted away the permafrost centimetre by centimetre. Inside, they found thick layers of fat, fully preserved organs, and connective tissue strong enough to test with surgical instruments. Samples of the hide revealed how the bison's fur had evolved to trap air, hollow hair fibres that insulated against extreme cold, much like modern muskoxen. Using carbon-14 dating, Blue Babe's age was determined to be around 36,000 years old. That placed it firmly within the height of the last Ice Age, when vast herds of steppe bison grazed Alaska's open plains alongside mammoths, horses, and woolly rhinoceroses. This period ended abruptly when climate warming and human hunting drove many of those species to extinction. Blue Babe wasn't just a skeleton though, it was still skin that could be touched. Scientists used chemicals to keep the bison alive and then treated its hide to keep it from breaking down quickly after it thawed. The fully repaired example was put on display at the University of Alaska Museum of the North in 1984. It is still one of the most famous Ice Age displays in the world. During its study, Blue Babe also helped answer questions about Ice Age ecology. Hair and bone isotope analysis showed seasonal changes in diet, proving that steppe bison migrated long distances between summer and winter pastures. Microscopic examination of stomach contents found traces of grasses, sedges and flowering tundra plants, evidence of a rich Arctic steppe environment that vanished when the climate warmed. Blue Babe, in essence, preserved not only itself, but a snapshot of a vanished world. The people who worked on the bison chose an odd way to enjoy their finding, which was a nod to both science and folklore. At a dinner to celebrate the end of the study, they cooked a small piece of Blue Babe's neck muscle in a stew as a way to connect current humans to people who lived in the Ice Age. Strong and old was how they described the taste, but it was one of the few times in history that people ate past. The Yakutia woolly rhino, a beast frozen mid-steppe. In August 2020, a group of reindeer herders exploring the melting steppe of Yakutia, Siberia, found something that looked like it came from a long time ago. Near the Terechtiak River, the permafrost was melting, and the bent horn of a rhinoceros could be seen. It wasn't a dinosaur, though. They found a woolly rhinoceros that was almost completely preserved. Its skin, thick fur and internal parts were all still in one piece, after being frozen in ice for over 34,000 years. The animal looked like it had been frozen in mid-stride, turning it from living thing. The creature, belonging to the extinct species Quelodonta antiquitatis, was found lying on its side, one leg still bent under the body. Its fur was a dusty brownish grey, with coarse hairs up to 30 centimetres long that once shielded it from the brutal Ice Age cold. Even the folds of its skin and the shape of its nostrils were preserved, giving scientists an unparalleled look at how this massive herbivore survived the frozen steppes of Pleistocene Siberia. The discovery site in Yakutia's Abiysky district is part of a region known for yielding Ice Age giants as the permafrost melts. But the condition of this rhino stunned experts. Its body still had muscles, fat deposits, and a nearly complete digestive tract. The stomach contents were examined at the Northeastern Federal University in Yakutsk and revealed chewed remains of grasses, sedges, and flowering plants. These were so well preserved that botanists could identify the species, evidence that the rhino had been grazing peacefully before death. Carbon dating placed it between 33,000 and 34,000 years old, during a relatively warm interglacial period when northern Siberia supported vast grasslands. This particular specimen wasn't the first woolly rhino found in Yakutia, but it was by far the most complete. In 2014, a calf named Sasha had been discovered nearby, but this adult rhino offered scientists a full view of the species in its prime. Its horn, still attached to the skull, was made of tightly packed keratin fibres, just like modern rhinos, though it was longer and more curved. The surface bore scratches and grooves, suggesting it had been used for clearing snow to reach buried plants or for fighting rivals. CT scans later revealed a smaller secondary horn on the nose, indicating a display structure similar to that of present-day Sumatran rhinos. This gave researchers new insight into the woolly rhino's behaviour, not just a slow grazer, but a strong, possibly territorial animal capable of using its horns as tools and weapons. The preservation was so extraordinary that scientists could even study microscopic details of the skin. Under electron microscopes, hair follicles and blood vessel impressions were visible, showing adaptations to life in extreme cold. The thick skin around the neck and shoulders, where fat reserves were concentrated, formed natural insulation layers, a built-in thermal armor. Traces of subcutaneous fat, still yellowish after thawing, provided further proof that woolly rhinos developed specialized energy reserves for surviving Arctic winters. Scientists still don't understand how such a big animal could have been kept so well. Most likely, they were suddenly trapped in a mudslide or icy bog and then quickly frozen. The fine-grained, soft permafrost around Tyrrhectia freezes tissue right away, making it last forever. Mammoth and bison mummies from the same area have been found to have been buried in similar, quick-freeze ways. This suggests that huge freezing events were common in the late Pleistocene. In 2021, geneticists successfully extracted DNA from bone marrow samples of the Yakutia rhino. Sequencing showed it was part of a distinct Siberian population, genetically isolated from woolly rhinos found farther west in Europe. The DNA also revealed genes linked to thick fur growth, cold-adapted blood proteins, and reduced sweat glands, traits that helped it thrive in sub-zero conditions. This data offered a clearer picture of how Ice Age megafauna adapted to climate extremes that would have killed most modern species. The innards inside the rhino still held a rare clue. The heart and liver could still be seen, though they were shrunken but whole. This let experts look at how its circulation system has changed. The walls of the heart chamber were bigger than in modern rhinos. This probably allowed for higher blood flow to keep the big animal warm when it was cold outside. It was a biological oven with armour around it. The Yakutia find also hinted at the species extinction story. Around 14,000 years ago, as temperatures rose, the mammoth steppe began to disappear. Grasslands gave way to wetlands and forests, forcing cold-adapted grazers like woolly rhinos toward extinction. Radiocarbon dating of the younger specimens suggests they vanished just before humans spread widely across Siberia, meaning climate change, not hunting, was likely the final blow. The cave lion cubs, Sparta and Boris. Two small animals slept through 28,000 years of ice and silence in the frozen tundra of Russia's Yakutia region, not far from the Kolyma River. When they died, they were cave lion cubs that were about the size of a house cat. Their golden fur was still soft, their whiskers were still noticeable, and their paws still had the soft pads they used to walk on. Scientists named the pair Sparta and Boris when they found them. Together, they are the best preserved big cat mummies ever found. The first cub, Boris, was found in 2017 by a local hunter exploring an eroded permafrost bank. Wrapped in frozen mud, the little lion appeared curled up, its head resting on its forelegs, as if asleep. 2 years later, in nearly the same spot, another cub emerged, this one even more complete. Sparta's fur was almost entirely intact, a soft beige coat with faint spots across the back, typical of young lions. Her teeth, claws, and internal organs were all preserved. Radiocarbon testing later revealed that the two cubs were not littermates. Boris was about 43,000 years old, while Sparta was 28,000 years old, separated by 15,000 years, yet buried in almost identical conditions. Both cubs belonged to Panthera spelaea, the Eurasian cave lion, a species that once roamed from Europe to the Bering Land Bridge. Larger than modern African lions and adapted for cold climates, they hunted reindeer, bison, and young mammoths across the vast mammoth steppe. The cubs' survival in perfect form owed everything to Siberia's permafrost, a natural freezer that locked them in time moments after death. When paleontologists at the Mammoth Museum in Yakutsk began thawing Sparta, they discovered a preservation level unlike anything they'd seen. Her fur retained its sheen, individual whiskers were visible under magnification, and even the delicate folds of the nose were undamaged. Dissection revealed a full set of internal organs: heart, liver, stomach, intestines, all shrunken but recognizable. Her brain, though partially collapsed, was still enclosed within the skull. Researchers could even see traces of blood vessels. This level of preservation allowed scientists to reconstruct in detail what an Ice Age lion looked like, not just bones, but muscles, skin, and colour. The cub's stomach contents gave us another unique look into their short lives. There were bits of fur and traces of mother's milk in Sparta's digestive system, which suggests she was still nursing when she died. Since there were no broken bones or bite marks on the CT scan, it's possible that she wasn't killed by an attacker. Scientists think she and Boris died suddenly, possibly because they were caught when the den fell, or because they were buried by a mudslide that froze quickly. Within hours, the cold buried them under layers of mud and ice, stopping the rot right away. The discovery also offered insight into the life cycle of cave lions. Before Sparta and Boris, knowledge of the species came mostly from skeletons and prehistoric cave paintings in France and Spain. Those paintings showed maneless lions, confirming that males of the species looked different from today's African lions. The cubs' coats, patterned with faint spots, proved that cave lion young shared camouflage similar to modern lion cubs, an adaptation to blend into tundra grasses while parents hunted. In 2021, an international team extracted DNA samples from the cubs' muscle tissue. The results revealed that cave lions were genetically distinct from modern lions, but close enough to interbreed, meaning hybrids could have existed where their ranges overlapped. The DNA also contained adaptations for cold climates, such as genes linked to thicker fur and fat metabolism. These genetic clues help scientists trace how large predators survived the harsh oscillations of Ice Age temperatures. Chemical isotope analysis along each strand showed fluctuations in their mother's diet during pregnancy, alternating between lean and rich periods. Seasonal changes that reflected the rhythm of Ice Age hunting. From this, scientists deduced that cave lion mothers gave birth in sheltered dens during colder months, much like modern lions seeking warmth and safety for their young. The baby mammoth, Dima, from the permafrost tomb. In 1977, gold workers in Siberia's Kolyma River Valley dug deep into the frozen ground and found a shape they had never seen before. It was small, grey, and had wrinkled skin that still looked living. The baby mammoth's body was so well kept that its eyelashes, trunk, and tiny toes were all still whole. People in the area named him Dima, after a stream nearby. What scientists found inside this little calf would change the way we think about how Ice Age giants lived, grew, and died. Dima was about 6 to 8 months old when he died, and radiocarbon dating placed his age at roughly 40,000 years. Unlike most mammoth remains, which are bones or hair fragments, Dima was a complete mummy. Every organ, muscle, and even the contents of his stomach were preserved. He became the first mammoth mummy ever studied in such complete biological detail, opening a new era in paleontology and Ice Age research. The discovery site lay within the permafrost of northeastern Yakutia, a region so cold that the ground remains frozen year-round. When Dima's body thawed slightly during excavation, researchers realized the preservation was astonishing. His skin was still elastic, his ears retained their shape, and his fur, fine, reddish-brown, and woolly, clung to his body. The mammoth's height measured just 104 centimeters at the shoulder, weighing about 100 kilograms, similar to a newborn elephant. His eyes were closed, his trunk curled gently under his chin, a posture so peaceful it looked as though he had simply fallen asleep. Inside, the story of Dima's short life was written in extraordinary detail. When Soviet scientists dissected him at the Zoological Institute in Leningrad, they found fully developed internal organs, including a heart, lungs, kidneys, and a digestive system packed with semi-digested grass, indicating he had recently eaten. In his intestines were traces of milk and plant matter, confirming that young mammoths were weaned gradually, a pattern similar to modern elephants. This discovery helped scientists understand the maternal behavior of mammoths, showing that calves likely depended on milk for many months while learning to graze on steppe vegetation. The tiny anatomy of Dima's bones and muscles was even more insightful. His tissue almost didn't show any signs of decay when looked at under a microscope. The fat cells stayed round, and the muscle fibers still had lines running through them. Later, chemical tests showed that collagen and myoglobin were present. These are proteins that don't usually stay in fossils. This was the first time that experts were able to look at mammoth health at the cellular level. They were able to see how these animals kept warm in the Arctic. Dima's cause of death remains one of the most debated topics in Ice Age paleontology. The evidence suggests he was healthy, but died suddenly. The leading theory is that he became trapped in a muddy depression or thawing permafrost pit, struggling until exhaustion. The soft sediment around him froze soon after, sealing his body almost instantly. Because his lungs and windpipe contained small amounts of silt, scientists believe he suffocated rather than froze to death. A tragic accident that paradoxically ensured his perfect preservation. The permafrost acted as a natural tomb, keeping his body locked in ice for tens of thousands of years. When he was finally unearthed, the world saw its first complete look at what a woolly mammoth really was. Not just bones and hair, but a real animal of flesh and emotion. His discovery became a symbol of Soviet paleontology and drew global attention to the incredible fossil potential of Siberia's frozen north. In 2012, renewed scientific analysis using modern imaging tools brought Dima back into the spotlight. CT scans revealed hidden structures inside his skull, including fully formed baby tusks just beginning to emerge. His brain cavity showed the shape and size typical of a modern elephant calf, suggesting mammoths shared similar levels of intelligence and social complexity. Isotopic analysis of his teeth and bone collagen also revealed the environmental conditions he grew up in. A cold, dry steppe with sparse vegetation, but rich in nutrients during the short summers. More recently, in 2020, a team from Japan and Russia analyzed small DNA samples from Dima's muscle tissue. Though degraded, enough genetic material remained to confirm his lineage as a pure woolly mammoth, Mammoths primigenius, closely related to the population that once roamed across northern Eurasia and into North America. His DNA continues to play a role in modern genetic studies exploring de-extinction, attempts to revive mammoth traits through cloning or genetic engineering of elephants. The giant short-faced bear from the glacial plains. There was a much bigger animal that lived on the Ice Age plains than polar bears or grizzlies. It was called the giant short-faced bear. It was one of the biggest land animals that ever lived. It stood over 3 meters tall and weighed almost a ton. For many years, most of the fossils of this animal came from bones that were buried in caves and frozen riverbeds. Scientists have seen pieces of a mummified short-faced bear in Alaska's icy core. These pieces, which still have muscle tissue and fur patches on them, show how big and strong this extinct animal really was. The remains were discovered in the late 1990s in the Old Crow region of northern Yukon, an area rich in Ice Age fossils preserved by permafrost. A team of paleontologists investigating thawing glacial deposits came across large bones protruding from frozen mud, ribs, a shoulder blade, and parts of a massive skull. When they began excavating, they found something no one expected: soft tissue. Embedded within ice were shreds of muscle fiber and dark matted fur still clinging to a portion of hide. Radiocarbon dating placed the remains at around 35,000 years old, near the height of the last glacial advance. The species, known as Arctodus simus, belonged to a now extinct group called the short-faced bears, predators built not for climbing or scavenging, but for running. Its long limbs, narrow body, and reduced snout gave it a strangely cat-like appearance. Unlike modern bears that shuffle with a lumbering gait, Arctodus moved with the stride of a sprinter. Its long legs allowed it to cover ground quickly, possibly chasing down prey across the tundra. The Alaskan fragments confirmed this athletic build. The preserved muscle fibers in the thigh showed remarkable density and fiber alignment, evidence of explosive power and endurance. The recovered fur, coarse and reddish-brown, surprised researchers. Chemical tests found traces of iron and copper minerals within the hair shafts, natural staining caused by thousands of years in glacial sediment. This explained the fur's metallic tint and helped identify environmental conditions at the time of burial. The bear likely died near the edge of a glacier-fed river, its carcass quickly frozen in silt as temperatures plummeted. Over millennia, glacial activity buried it deeper under successive layers of ice and mud, keeping it in near-perfect cold storage. For years, Arctodus simus had been the subject of fierce scientific debate. Some believed it was a pure carnivore that dominated Ice Age ecosystems, preying on horses, bison, and even mammoths. Others argued it was primarily a scavenger, using its long legs not for chasing prey, but for patrolling vast distances in search of carcasses. The soft tissue fragments from Alaska added crucial data. Analysis of nitrogen isotopes in preserved collagen suggested a high-protein diet, consistent with apex predation. Its teeth, broad, sharp-edged molars, also showed wear consistent with tearing meat rather than grinding vegetation. By comparing the preserved bone density to that of modern brown bears, scientists found Arctodus was much lighter for its size, a biological trade-off favouring speed. Its limb proportions resembled those of wolves or big cats more than modern bears. This means that on open glacial plains, it could likely run faster than most large mammals of its time. Reconstructions suggest a sprinting speed of up to 50 kilometers per hour, staggering for an animal weighing nearly a ton. One of the most fascinating facts about the glacial find was that some of the bear's paw pad was still there. The thick, dark skin had deep wrinkles that helped it grip snow and ice. This was real proof that Arctodus could move quickly across frozen ground. This change may help explain why it lives in such a large area, from Alaska and the Yukon to what is now Mexico. It was in charge of North America for about 400,000 years, as shown by fossils. Arctodus vanished around 12,000 years ago, just as the Ice Age ended. The reasons remain uncertain. As the glaciers retreated, grasslands gave way to forests, and many of its prey species, like steppe bison and horses, declined or migrated north. Without open plains or abundant food, the giant bear may have been outcompeted by smaller, more adaptable brown bears and the first human hunters crossing the Bering Land Bridge. The specimen's remaining hide, still displayed in a refrigerated chamber at the University of Alaska Fairbanks, retains faint traces of fur that shimmer reddish under light. To stand before it is to confront a ghost of the Ice Age, an animal so large and confident that it feared nothing. In life, it ruled a world of frozen grass and bitter wind. In death, it became one with the glacier that preserved it. The woolly rhino calf Sasha. A group of gold miners found something small and strange coming out of the melting permafrost in the Sakaya Republic, Yakutia, in Siberia's faraway tundra in 2014. It was the body of a young woolly rhinoceros. It was so well kept that you could still see its eyebrows, skin folds, and a thin layer of reddish fur. The cow kid was named Sasha, after the daughter of one of the guys who found her. She was only a year old when she died, but Sasha's body was found to be in such perfect condition that it became one of the most important science finds of the Ice Age. The discovery took place along the Semyulyak River in Yakutia's Abyesky district, a region already known for mammoth and bison remains. But what made Sasha different was her completeness. Her body measured about 1.5 meters long and weighed roughly 40 kilograms when thawed, nearly intact, except for minor damage to one ear. Thick, cinnamon-colored fur still clung to her sides, showing that even young rhinos of the Ice Age possessed dense coats for Arctic survival. Her skin was soft, slightly wrinkled, and tinged brown from iron minerals in the soil, a sign that permafrost had preserved her without decay for around 34,000 years. When scientists from the Mammoth Museum in Yakutsk examined her, they found an astonishing level of preservation. The hooves were intact, the horn base remained attached, and even the inner ears and nostrils were visible. The remains of 2 small horns, one on the snout and a developing secondary horn above it, offered rare evidence of how woolly rhinos grew their famous weapons. CT imaging showed that the base contained a network of blood vessels, suggesting rapid keratin growth during the calf's early months. When dissected under laboratory conditions, her stomach and intestines revealed fragments of partially digested grasses, sedges, and herbs, all typical steppe vegetation. Under microscopes, the plant fragments were so fresh that some retained their original colour. From this, paleobotanists reconstructed her habitat as an open, treeless tundra steppe, with short grasses and patches of wildflowers. A cold but productive environment that once stretched across Siberia during the late Pleistocene. To determine Sasha's diet and seasonal environment, scientists analysed stable isotopes from her hair and bone collagen. The results showed clear seasonal variations in carbon and nitrogen ratios, meaning she had lived through at least one cycle of Arctic summer and winter before death. These findings proved that woolly rhinos raise their young year-round in frigid climates instead of migrating long distances, as mammoths sometimes did. The calf's fur itself carried a chemical signature of its surroundings, trapped dust particles containing traces of ancient volcanic ash, linking her life to one of Siberia's prehistoric eruptions. Her cause of death remains uncertain, but the evidence points to sudden freezing. There were no bite marks or fractures on the bones, and her body position, with legs tucked under and head slightly tilted, suggested she may have become stuck in a muddy hollow or frozen pond. When the temperature dropped abruptly, the slush around her solidified into ice, encasing her completely. Within hours, decomposition would have stopped. Over time, the surrounding ground transformed into permanent permafrost, sealing her body for tens of millennia. After Sasha's finding, scientists could study the woolly rhino's body in a way that had never been possible before. Her thick skin, which was almost a centimetre thick in some places, showed how these animals kept from getting frostbite. Under it were layers of subcutaneous fat, some of which was still yellow after melting and acted as protection, like the blubber that Arctic whales have. DNA taken from her muscle tissue and bone marrow proved that she was of the right species and found the genetic change that caused her fur to be thick and her metabolism to be slow, which were both necessary for her to survive the long, cold winters of the Ice Age. The most amazing thing about her organs is that they still had proteins like keratin and collagen that are very similar to those found in current rhinos. This meant that the biological makeup of rhino skin hasn't changed much over hundreds of thousands of years. Geneticists compared Sasha's DNA to that of current Sumatran and white rhinos and found that her lineage split about 14 million years ago. However, she shared some genes that help her survive in cold places with Arctic animals like muskoxen. The giant muskox, frozen beneath Arctic ice. In 2019, the remains of a huge Ice Age grazer were found in northern Siberia's melting permafrost. They had been hidden for tens of thousands of years under layers of Arctic frost. At first, reindeer farmers thought they saw a buried log, but it turned out to be the preserved body of a giant muskox, complete with thick wool, leathery skin, and even pieces of internal tissue. This ancient animal, which was bigger than any living muskox, walked the frozen steppes with mammoths, bison, and woolly rhinos. Now that it is frozen, experts can see how animals that were used to living in cold places survived the harsh temperature of the Pleistocene. The discovery came from the Yuka River basin, in a region where melting permafrost often releases mammoth tusks and bones. But unlike ordinary fossils, this specimen retained flesh, hide, and a full coat of underfur, a level of preservation almost never seen outside of mammoths. When researchers from the Mammoth Museum of Yakutsk arrived, they found the torso, forelimbs, and skull embedded in frozen silt. The horns, long and curved downward like scimitars, measured nearly a metre from base to tip. Radiocarbon dating placed the animal's death at around 36,000 years ago, during one of the coldest peaks of the last Ice Age. The muskox, known scientifically as Ovibos palantis, or sometimes classified within Praeovibos, was the ancestor of modern muskoxen, Ovibos moscatus. It was bulkier and more heavily muscled, with a body designed for endurance across glacial grasslands. The preserved hide revealed a two-layered coat, long, coarse outer guard hairs, and a dense, wool-like undercoat called kiviot, one of the warmest natural fibres known. Samples taken from the mummy confirmed that the chemical composition of its keratin matched that of living muskoxen, proving that their cold weather insulation system has changed little in 40,000 years. When scientists began thawing the specimen in controlled conditions, they noticed the unmistakable odour of organic decay, a sign that parts of the body still contained original tissue. Inside, they found remnants of muscle, fat, and even pieces of the stomach wall. Under microscopes, the muscle fibres displayed faint reddish pigmentation, preserved hemoglobin residues that had survived the freeze. The stomach contents were a mix of dried grasses, sedges, and small twigs, revealing that this animal had been feeding right before it died, possibly caught in an unexpected blizzard or sudden ground collapse. Stable isotope analysis of the preserved bone collagen showed that the giant muskox fed primarily on C3 plants, typical tundra vegetation, and that it lived in an environment with extreme seasonal swings. The oxygen isotope ratios matched those found in mammoth remains from the same layer, suggesting that the region experienced harsh winters followed by brief, lush summers. These data helped scientists model the ancient ecosystem, a wide, treeless steppe stretching from Alaska to Siberia, dominated by hardy grazers like muskoxen. Geologists studying the site found evidence of periglacial flooding, when meltwater pools refreeze suddenly, trapping anything in its path. The muskox may have fallen into a mud-filled gully or pond during a thaw and then been sealed as temperatures plummeted. The mud acted like plaster, isolating the carcass from air and bacteria. Over thousands of years, permafrost and mineral-rich water reinforced the tissues, turning the animal into a natural mummy rather than a fossil. When looked at more closely, incredible details about its body were revealed. There were signs of growth in the thick skin around the shoulders. This is an increase of connective tissue that likely helped the big neck muscles hold the heavy head in place as they swung it through snowdrifts. The growth rings on the surviving horn sheaths showed how old the animal was, about 10 years old. These rings also had microscopic mineral bands that showed the changing of the seasons. These bands were like tree rings from the Ice Age and helped scientists figure out when food was plentiful and when it wasn't throughout its life. Genetic sequencing performed in 2022 on bone marrow samples revealed that this specimen carried unique mitochondrial DNA not found in modern muskoxen. It belonged to a lineage that disappeared roughly 20,000 years ago, when glaciers retreated and open steppes gave way to wetlands and forests. The data showed a dramatic population bottleneck. As climates warmed, the giant muskox lost its wide grazing lands and was replaced by smaller, more compact descendants better suited to marshy terrain. The steppe mammoth skull encased in Siberian ice. A group of local fossil hunters found something so huge in the permafrost of Yakutia's Milek River region in the summer of 2015. It took a helicopter to lift it off the ground. The head of a steppe mammoth was frozen solid. Its tusks were curled like frozen lightning bolts and were about 5 meters long from tip to tip. The bone was still pale and strong after being buried for more than 400,000 years, and the head was still whole. Paleontologists saw it as one of the oldest and biggest mammoth bones ever found. It gave them a clear look into the early growth of the giants that would become the woolly mammoth. The steppe mammoth, Mammothus trogontherii, was the largest elephant species to ever roam Eurasia, towering up to 4 meters tall at the shoulder and weighing around 10 tons. It thrived during the Middle Pleistocene, long before the last Ice Age peaked. Unlike its shaggy descendants, the steppe mammoth had a thinner coat of fur and longer limbs, built for migrating across endless plains. Its discovery in such a state of preservation shocked scientists because the bones were not mineralized. They were real bone, frozen solid, still carrying traces of organic material. When the ice was carefully thawed around the specimen, researchers saw that the skull was positioned upright, as if the animal had died standing or fallen forward into slush. Both tusks were still attached, slightly twisted at the base from years of natural growth. Each tusk weighed over 80 kilograms and showed a spiral pattern unique to steppe mammoths, tighter and more compressed than those of woolly mammoths, suggesting a different feeding or digging behavior. The sheer size of the skull made it clear this was no young animal. CT scans later estimated its age at over 50 years when it died. It was astounding how good the bone looked. Inside the marrow spaces, there was still dried collagen and fat that had been kept, which is a very rare sign of something that is hundreds of thousands of years old. The inner tusk pulp's DNA test showed that it belonged to Emsure trogontherii and not a later mixed species. That genetic material helped solve a long-standing puzzle. Steppe mammoths were related to both woolly mammoths and the Columbian mammoths that lived all over North America. They were the link between the earliest elephants and the giants that came after the Ice Age. The surrounding sediment revealed the story of its burial. The skull had been encased in alternating layers of ice and silt, meaning it was buried during multiple freeze-thaw cycles. Geologists determined that the area was once a floodplain, periodically covered by meltwater from nearby glaciers. The mammoth likely died near one of these rivers, its carcass partially submerged. Over time, freezing mud engulfed it, preserving the upper skeleton while the rest disintegrated. When modern climate change began melting the region's permafrost, the skull re-emerged after nearly 500,000 years of darkness. It was different from what the tusk said. Like tree roots, the inside of mammoth tusks has growth rings, with each ring marking a year of life. Scientists found hundreds of tiny rings when they cut a small piece. Changes in the oxygen and nitrogen isotopes inside those rings showed how the animal's food and surroundings had changed over many years. The isotopes showed that it ate a lot of temperate plants when it was young, which suggests that it lived in warmer conditions. Later, the makeup changed, with years that were colder, drier, and had less greenery. Basically, the tusks kept a personal record of the weather during the Ice Age as it happened. One of the greatest surprising things experts found was that air bubbles were stuck in the ice around them. The samples showed that the atmosphere from a long time ago had a little more carbon dioxide than usual for that time. This finding taught climatologists a lot about how ecosystems worked in the early glacial period, before the full Ice Age started. The mammoth's ice grave held both a body and the air it used to breathe. In 2021, a joint team from Russia and Sweden successfully extracted mitochondrial DNA from the skull and compared it to woolly mammoth genomes. The results showed that steppe mammoths carried genes for both warm and cold adaptation, thickened skin proteins, yet less fur density than their descendants. These genetic blueprints helped reveal how evolution equipped later mammoths to survive harsher climates. It was the missing link between tropical elephants and the woolly icons of the Ice Age. The cave lion adult found frozen with its fangs intact. Russia's Belaya, Gora region in Yakutia's icy wilderness in 2021 was the site of a find so rare that it shocked even experienced paleontologists. The mummified body of an adult cave lion was stuck in the melted permafrost. The skin, muscles, and all of its sharp ivory-coloured teeth were still there. For decades, only cubs like Sparta and Boris had been found to be in such perfect shape, but this was something completely different. A fully grown animal from the Ice Age, frozen in a pose that made it look like its life had stopped in the middle of a movement. The specimen, later nicknamed Spartac by scientists, was found lying partly on its side, forelimbs folded, the head turned slightly as if scanning the tundra. When excavated, the animal measured over 1.3 meters from nose to tail base, about the size of a small modern lion, and weighed roughly 40 kilograms when thawed. Radiocarbon dating placed it at around 30,000 years old, the same era when mammoths, bison, and woolly rhinos roamed the steppe. Yet unlike bones or skeletons, Spartac's body still carried the marks of muscle fibers and faint traces of golden brown fur that once glimmered under an Ice Age sun. Cave lions, Pantheris belea, were among the most powerful predators of their time, larger and stronger than modern lions, with thicker coats and shorter ears to survive the cold. They hunted across Eurasia's mammoth steppe, feeding on horses, deer, and young mammoths. But their remains rarely appear in such lifelike conditions because large carnivores seldom died in freezing environments that could preserve flesh. That's what makes Spartac's discovery extraordinary. A once-living killer, captured perfectly by the ice that ended his world. The body was excavated by a team from the Northeastern Federal University in Yakutsk, led by Dr. Albert Protopopov, the same scientist who studied the cave lion cubs found earlier. The adult lion's skin was still elastic, though leathery, and patches of fur clung to its shoulders and haunches. Its mouth, slightly open, revealed a stunning sight. Intact canines nearly 8 centimeters long, gleaming white even after 30 millennia. The teeth were sharp and unbroken, and their wear patterns showed the lion had reached full maturity but was still in prime condition. It had likely been an active hunter before its sudden death. Researchers believe the lion died in a mudflow or rapid freeze event, possibly after falling into a riverbank pit during a seasonal thaw. When temperatures plummeted, the body was encased in ice within hours. The lack of scavenger damage and the pristine preservation of the fur support this theory. Nearby sediment layers showed alternating frozen and melted zones, evidence that the carcass had remained sealed during cycles of permafrost expansion and contraction for tens of thousands of years. When the body was CT scanned in 2022, scientists found well-preserved internal organs: lungs, liver, heart, and intestines. Even the diaphragm was intact, something never before seen in a large Ice Age predator. This allowed researchers to estimate body mass and breathing volume, confirming that cave lions had extremely powerful chests suited for short bursts of energy and ambush-style hunting. Analysis of the stomach cavity revealed traces of soft tissue and broken bone fragments from prey, possibly steppe bison or reindeer. Spartac's fur, still golden with darker stripes faintly visible on the legs, provided key insight into camouflage. Earlier cave lion art found in Paleolithic caves showed lions without manes, and this specimen confirmed the observation. There was no sign of mane growth on the scalp or shoulders. The smooth fur pattern suggests that male cave lions lacked manes entirely, likely an adaptation for shedding heat during hunts or for avoiding frost buildup in snow. Their maneless appearance also means prehistoric humans, who painted them on cave walls, portrayed them accurately from first-hand encounters. Genetic material from Spartac's bone marrow helped complete the evolutionary picture. Sequencing revealed close similarity to both European and North American populations, proving that cave lions crossed the Bering Land Bridge during the Ice Age, spreading from Siberia into Alaska. These lions later gave rise to the now extinct American lion, Panthera atrox, the largest cat species ever known. DNA markers also confirmed that cave lions carried adaptations for cold tolerance, genes affecting hair growth and metabolism similar to those of snow leopards. Another wonderful aspect about Spartac was how good his claws looked. Each one was fully coated, sharp, curved, and had small bumps on it from being used all the time. The keratin structure could still be seen when looked at under a microscope. The lion's paws were frozen quickly and were never moved, as shown by their high level of preservation. Even the tiny dust on his paw pads was the same as the dirt in an Ice Age desert. It was frozen proof of the last surface he walked on. The Yukon bison stampede locked in ice. It was 2016 and workers were digging through permafrost for a road project near the White River Valley in Yukon, Canada. They came across what looked like a pile of twisted logs. When they warmed the frozen ground though, they found something amazing: bones instead of wood. Several dozen huge bison skeletons grouped together. They are all from the Ice Age. It looked like the bodies were stacked in a mess, but the hooves were still lined up as if they were running. The dig showed a frozen tragedy, a herd of bison that got stuck in glacial mud that had frozen solid over 18,000 years ago and would never move. The steppe bison, Bison priscus, was one of the dominant grazers of the Pleistocene, roaming across Siberia, Alaska, and North America in enormous herds. These animals stood nearly 2 meters tall at the shoulder, with curved horns and thick, woolly coats, adapted for the cold. Their fossils are common across the Arctic, but rarely are multiple individuals found together in pristine condition. The Yukon discovery was different. It showed an entire herd frozen mid-motion, victims of a disaster that struck within minutes. When paleontologists from the Canadian Museum of Nature and the University of Alberta began studying the site, they found at least 14 partial or complete bison skeletons preserved in a single layer of silty ice. The animals were all adults or subadults, positioned as if running in the same direction. Beneath them lay a thin stratum of frozen gravel, evidence of a sudden flood event. The theory that emerged was both tragic and fascinating. The herd may have been crossing a glacial river when an ice dam collapsed upstream. The resulting surge of freezing water swept them away, burying the animals instantly in slush that solidified before decomposition could begin. Some of the remains still bore fragments of fur, skin, and connective tissue. The hair, coarse and reddish-brown, had been mineralized by the permafrost but still retained the layered insulation structure typical of Ice Age grazers. On several skulls, the horns were still attached, the keratin sheaths preserved beneath ice. When scientists carefully cleaned and scanned the bones, they noticed unusual details: mud-filled nasal cavities, lungs collapsed inward, and limbs flexed in natural positions. These signs pointed to rapid drowning and freezing, rather than long-term decay. Chemical tests performed on the surrounding sediments revealed a mixture of fine silt and volcanic ash from a known eruption dated to about 18,400 years ago. This layer acted as a geological timestamp, confirming the event occurred during the last glacial maximum. It also suggested a chain reaction. Volcanic activity may have triggered rapid melting or destabilization of nearby glaciers, causing the sudden flood that entombed the herd. This kind of flash freeze burial explains the remarkable state of preservation, similar to what scientists have seen in mammoth and rhino mummies from Siberia. Stable isotope analysis of the bison's bones told an even deeper story. Variations in carbon and nitrogen levels revealed the herd's diet in their final weeks, rich in sedges and steppe grasses, indicating late summer or early autumn. This seasonal detail fits the scenario perfectly. During this time, herds migrated southward along river valleys to escape the approaching cold. They likely attempted to cross a swollen glacial river at the wrong moment. Within hours, the temperature plummeted, sealing their fate under ice and silt. The find also provided insight into Pleistocene herd behavior. The alignment of the skeletons and the close spacing between individuals mirrored patterns seen in modern bison stampedes, where panic and group motion override individual survival. It's possible that one or two animals slipped or became trapped, triggering a chain reaction that sent the rest tumbling into the freezing torrent. The permafrost preserved not only the bodies but also the motion, a frozen moment of chaos from an ancient landscape. Some frozen bison hearts and muscle pieces found in the ice were some of the most remarkable finds found at the site. Even though they were very dry, they still had shape under a microscope, which showed the striations of heart muscle. Trace proteins, which are leftovers of collagen and myoglobin, were taken from these samples by scientists. These proteins gave them signs about how these huge animals controlled heat and oxygen in cold places. It was the first time that molecular information from a group of steppe bison had been collected and kept together. By comparing genetic material from the Yukon specimens to that of Alaska's famous blue babe mummy, researchers confirmed they were the same species, but from slightly different populations. The Yukon herd carried genetic markers indicating they lived closer to the glacial front, an area with harsher winters and sparser food. This may explain why they migrated long distances, a dangerous strategy that ultimately led them into disaster. The DNA also showed evidence of low diversity, suggesting that by this time, steppe bison populations were already declining, a sign that the end of the Ice Age was beginning to reshape their world. The prehistoric horse with liquid blood still inside. In 2018, deep inside the Batagaika crater of Siberia's Yakutia region, a team of Russian and Japanese scientists uncovered a discovery so well preserved it seemed impossible. As they chipped through layers of frozen mud, they revealed the body of a 42,000-year-old foal, a baby prehistoric horse, so intact that its skin, muscles, tail and mane still looked freshly buried. Even more shocking, when researchers made a small incision during examination, dark red liquid blood began to flow. For the first time in history, scientists were looking at real Ice Age blood, fluid that had survived tens of thousands of years sealed in the Arctic cold. The find came from one of the most scientifically valuable permafrost sites on Earth. The Batagaika crater, nicknamed the Gateway to the Underworld, is a massive thermokarst depression formed by melting ice layers that reveal ancient sediment each year. In this constantly shifting landscape, paleontologists from the Northeastern Federal University of Yakutsk and Kindai University of Japan recovered the foal's body from about 30 meters below the surface. The animal, just 2 months old when it died, belonged to an extinct species known as the Lenskaya horse, Equus lenensis, a close ancestor of modern Yakutian horses still living in the region today. The foal's preservation stunned the world. Its coat, short and chocolate brown, was unbroken by decay. The hooves were firm, the eyelashes intact, and the tiny nostrils still dusted with frozen soil from the Ice Age steppe. CT scans showed that every internal organ, heart, liver, lungs, intestines, remained in place. Unlike most mummified fossils, which lose all fluid content, this specimen retained liquid biological material, including blood and urine. When scientists thawed part of the chest cavity, droplets of red fluid began to emerge. Laboratory analysis confirmed it wasn't contamination. It was genuine, hemoglobin-rich blood that had somehow resisted coagulation for 42 millennia. The key to this miracle was rapid freezing and stable sub-zero temperature. Shortly after the foal's death, likely from drowning in soft permafrost mud or a flash-flooded pit, the body became entombed in oxygen-free ice. Without exposure to bacteria or air, the tissues dehydrated and froze instantly, preserving cell structures at a microscopic level for tens of thousands of years, acting as nature's perfect cryogenic vault. Even the animal's internal fat deposits were found in near original condition, providing clues about Ice Age metabolism and body temperature regulation. The discovery of liquid blood opened new scientific possibilities. Researchers successfully extracted intact red blood cells, the oldest ever recovered, and examined them under a microscope. Their circular shape and flexible membranes matched those of living horses. This level of preservation meant that, for the first time, scientists could study Ice Age cellular biology directly, instead of relying on fossilized impressions. The blood even contained traces of plasma proteins, providing data on how Iron Age animals adapted their oxygen transport systems to cold conditions. The preserved organs told an equally detailed story. The stomach contained traces of digested milk and partially chewed grass, evidence that the foal had just begun transitioning from nursing to grazing before death. Isotopic analysis of bone collagen revealed that its mother had fed in open tundra meadows, rich in sedges and wildflowers. The soft tissue around the lungs and heart showed that the foal had healthy development, not due to disease or malnutrition. Every clue pointed to an accident, perhaps a young animal straying too close to unstable ground during a thaw. In 2019, Japanese researchers at Kindai University made headlines by attempting to extract living cells from the preserved muscle tissue. Their goal wasn't to clone the horse directly, but to test whether any cell nuclei still held intact DNA. Although no living cells were recovered, fragments of DNA remained strong enough for partial sequencing. The genetic data confirmed the Lenskaya horse's close relation to modern Yakutian horses, which are uniquely adapted to extreme cold. This discovery revealed a continuous evolutionary lineage lasting over 40,000 years, from Ice Age tundra to modern Arctic villages. The preserved blood and soft tissue also reignited global interest in de-extinction research. Scientists from the Mammoth Revival Project in South Korea and Russia began exploring ways to use preserved genetic material from Batagaika animals to reconstruct Ice Age genomes. Though full cloning remains far beyond reach, the foal's blood serves as a model for studying long-term DNA survival, a key step towards someday reviving extinct cold-adapted species. The giant ground sloth, frozen in Andean ice. In 2020, high in the Andes Mountains in southern Peru, a group of paleontologists studying a melting glacier found something that didn't make sense and was very high up, nearly 4,800 meters above sea level. The partly frozen body of a giant ground sloth was wedged between two blocks of glacial ice. The animal's huge claws were curled inward, and its hide still had rough strands of fur on it. It is thought that this Ice Age giant lived about 13,000 years ago. It had been frozen where it fell because the air in the Andean peaks is so thin and cold. The animal belonged to the genus Melodon, one of the largest ground sloths ever to exist. In life, it would have stood more than 3 meters tall when reared on its hind legs and weighed nearly 2 tons. It was a slow-moving herbivore covered in long reddish-brown fur, with skin reinforced by tiny bone-like plates called osteoderms, which acted like natural armor. Though most known Melodon fossils came from caves in Chile and Argentina, this was the first specimen ever found encased in mountain glacier ice, far above its usual lowland habitat. The find occurred near the Quelccaya ice cap, one of the world's largest tropical glaciers. As global temperatures warmed and the glacier retreated, sections of ancient ice began to collapse, exposing layers of frozen organic material. The team, led by researchers from the National University of San Marcos, noticed an unusual shape protruding from the ice, thick fur, and a curved bone resembling a claw. When excavated, it revealed a large forelimb attached to a partial torso, hide, and one hind leg, all still connected by tendons hardened by cold. The surrounding ice contained plant fragments, pollen, and even insect remains. A frozen ecosystem preserved alongside its colossal inhabitant. Radiocarbon testing dated the specimen to roughly 12,900 years ago, placing it at the very end of the Pleistocene epoch, just before the giant sloths went extinct. Its presence at such a high altitude surprised scientists, suggesting that Melodon had ventured into mountain valleys during cooler climate phases in search of food. The preserved stomach contents, later examined under a microscope, contained chewed remains of grasses and Andean sedges, proof that this massive animal grazed on high-altitude vegetation now buried under ice. The cause of death appeared to be a sudden glacial storm or rapid freezing event. The animal likely became trapped in a snow-filled ravine during a seasonal migration and was buried by an avalanche. The combination of cold, low oxygen and ice prevented decomposition, turning the carcass into a natural mummy. When thawed in the lab, its skin remained thick and leathery, covered in coarse hair that still retained its reddish hue. Beneath the fur, the osteoderms glinted like tiny pebbles, the same structures that once puzzled Charles Darwin when he first encountered Melodon remains in Patagonia in the 1830s. CT imaging of the preserved tissues revealed surprising details about Melodon's internal structure. The muscles of its forearms were exceptionally developed, confirming that it used its long claws not for climbing trees, but for digging roots and tearing branches. The claw itself, still attached to the hand, measured nearly 30 centimeters long, curved and sharp even after thousands of years. Underneath the hide, traces of subcutaneous fat showed that the sloth stored energy reserves similar to modern bears, allowing it to endure long winters or food scarcity at high altitudes. The sloth's fur led to one of the most noteworthy discoveries. Scientists looked at tiny air bubbles stuck in individual hairs and found signs of the climate during the Ice Age, including slightly higher amounts of carbon dioxide and volcanic dust particles. This was clear proof of how Melodon's world was changing near the end of its time. The sloth's body had basically turned into a biological time capsule that recorded the last few seconds before the species went extinct. DNA extracted from bone marrow confirmed that this Andean sloth was part of a northern branch of the Melodon family, a lineage distinct from the famous Patagonian populations. Genetic markers revealed strong cold adaptation traits, including thicker hair follicles and blood proteins capable of retaining oxygen efficiently in thin air. These adaptations likely allowed Melodon to thrive temporarily in mountain regions where few megafauna could survive. The discovery also reshaped understanding of Ice Age migration patterns in South America. The Andes, once thought to be an impassable barrier for large mammals, may have served as temporary corridors during glacial expansions. As glaciers advanced, sloths and other herbivores followed newly opened valleys rich with vegetation. When the climate warmed abruptly about 12,000 years ago, these paths vanished, trapping populations in isolated pockets and eventually driving them to extinction. The Beringian lion of the ice caves. A permafrost cave near the Semyulyak River in northeastern Yakutia was the site of a huge scientific find in 2019. Miners were looking for mammoth ivory when they made it. The body of a huge Ice Age lion was buried in frozen ground. It was bigger than any current big cat and amazingly well preserved. Under its pale golden fur, you could still see its muscles. When its lips thawed, they showed sharp, jagged teeth that looked ready to tear through flesh. There was no baby here like Sparta or Boris. This was a full-grown Beringian lion, which is one of the most dangerous animals that has ever lived on the steppe. The specimen, estimated to be around 50,000 years old, belonged to Panthera spelaea vereshchagini, a northern subspecies of the Eurasian cave lion that once roamed across Siberia, Alaska, and parts of Canada. Standing over 1.2 meters at the shoulder and weighing up to 350 kilograms, it rivaled modern tigers in size and exceeded them in strength. These lions ruled the so-called Mammoth steppe, an ecosystem rich in bison, reindeer, and young mammoths. Fossil evidence long hinted at their presence, but never before had scientists seen one preserved with flesh, fur, and bone intact. When paleontologists from the Northeastern Federal University of Yakutsk excavated the carcass, they found it lying on its side in compacted ice. The head was tilted upward, mouth slightly open, revealing a perfect set of massive canines, still white after tens of millennia. Its eyes had collapsed, but the facial muscles remained so defined that scientists could reconstruct its expression. The paws were padded, the claws curved, and individual whisker paws still dotted the muzzle. Radiocarbon analysis confirmed its age, placing it in the late Pleistocene, during one of the coldest glacial phases. The discovery was especially significant because it provided the first tangible look at adult Ice Age lion physiology. Until then, knowledge of these predators came mostly from skeletons and Paleolithic cave art, but this frozen body told the story of how Beringian lions survived in freezing temperatures that would have crippled most big cats. Beneath the fur, the animal's skin was thick and leathery, and chemical analysis showed traces of subcutaneous fat, insulation unknown in modern lions, but essential for Arctic life. CT scans of the lion's chest and shoulders revealed exceptional muscle mass, particularly around the forelimbs and neck. This build suggested short, explosive strength rather than long chases, evidence that Beringian lions hunted by ambush, tackling prey in snow and ice. Their prey list, reconstructed from bite-marked fossils in nearby layers, included steppe bison, horses, and even juvenile mammoths. The lion's tooth wear pattern supported this: shallow scratches and clean enamel, typical of animals that consumed fresh meat rather than scavenge carcasses. Inside the stomach cavity, researchers found microscopic bone shards and traces of myoglobin, the muscle pigment that gives meat its red color. These fragments were chemically matched to ancient reindeer DNA, confirming what this predator had eaten just before death. How it died, however, remains uncertain. Some scientists believe the lion fell into an ice crevasse or water-filled depression during a hunt and froze almost instantly. The lack of trauma or broken bones supports the idea of a sudden, peaceful death, a hunter caught mid-pursuit by the cold itself. Under magnification, it showed a dense undercoat hidden beneath long guard hairs, similar to modern lynxes or snow leopards. This adaptation would have allowed it to live year-round in sub-zero climates. Traces of black pigment near the main area suggested faint striping or shading, perhaps camouflage against the tundra's patchy light and shadow. The mane, if present at all, was short and thick, reducing heat loss and frost buildup. Genetic sequencing of tissue samples in 2022 revealed that Beringian lions were genetically distinct from their European cave lion relatives. Their DNA carried unique mutations linked to cold tolerance and larger body size. Interestingly, these lions interbred with early populations of American lions, Panthera atrox, across the Bering Land Bridge, explaining fossil overlaps found in Alaska. This genetic exchange made them apex predators on both continents, the northern kings of the Ice Age. The woolly mammoth family found beneath the glacier. In 2019, some reindeer hunters near the Katanga River Valley on Siberia's Taimyr Peninsula found something that was like opening a time capsule frozen in ice. Two huge curved tusks, one much smaller than the other, came out of a wall of melted ice. When archaeologists dug up the site, they found something amazing. A mother woolly mammoth and her calf that had been frozen together in a layer of ice for over 28,000 years. Their bodies, which still had patches of reddish-brown fur on them, were perfectly lined up, creating a disturbing picture of motherly instincts frozen in time. The find quickly drew attention from the Mammoth Museum in Yakutsk, which dispatched a scientific team to recover the remains before thawing destroyed them. The excavation revealed that the adult mammoth was roughly 2.7 meters tall, likely a young female, not yet fully grown, while the calf stood just under 1 meter high. Both had intact skin, hair and organs, making them among the best preserved mammoth mummies ever found. The pair appeared to have died together, trapped in mud that rapidly froze after a sudden flood or glacial collapse. The mother's trunk was still curled protectively toward the calf, whose body rested against her front leg. The posture stunned paleontologists. It wasn't random positioning caused by sediment, but clear evidence of an emotional bond captured at the moment of death. This was the first discovery of its kind showing a mammoth family preserved in situ, not just individuals. Radiocarbon analysis dated the pair to the late Pleistocene, a time when vast herds of mammoths roamed Siberia's tundra. Nearby sediments were rich with grass pollen, sedge roots, and ancient insect fragments, revealing that the region had been a fertile steppe, teeming with life. The mother's stomach contents were particularly telling. Over 70 species of partially digested plants, including buttercups, yarrow, and dwarf birch leaves. These samples allowed scientists to reconstruct her final meal and even the season of death, likely late summer, when tundra flowers were in full bloom. The calf, only about 6 months old, had traces of milk in its stomach along with bits of chewed vegetation, showing it was transitioning from nursing to grazing. Isotopic testing of its hair showed a steady pattern of nitrogen absorption, consistent with rapid growth during its short life. Under electron microscopy, the calf's fur revealed two distinct layers, an insulating undercoat and longer guard hairs, proving that even the youngest mammoths were fully adapted to Arctic cold. One of the most noteworthy finds they found was in the mother's trunk. Scientists looked at the well-preserved inside and found tiny bits of silt, pollen and water plants. It looked like the mammoth had been hunting near a river or ice pond when something bad happened. They were found in mud that clearly had the ripples of a flash flood, which could have been caused by melting ice or permafrost that has given way. Within minutes, the animals could have become stuck in sludge that freezes quickly, and their heavy bodies would have made it impossible for them to get out. As the excavation progressed, thermal scanners showed the surrounding ice layers contained small bubbles of ancient air. When extracted and analysed, the gases provided a snapshot of the late Ice Age atmosphere, slightly lower in carbon dioxide and higher in dust content than today. This environmental data offered scientists a precise look at the harsh world in which mammoths lived, a place of extreme cold, punctuated by brief bursts of warmth that could melt rivers and create deadly traps. Genetic samples taken from both the mother and calf confirmed they were pure Mammothus primigenius, woolly mammoths, and that they shared identical mitochondrial DNA sequences, confirming direct maternal relation. The analysis also revealed unique genetic markers for thick fur density and cold-resistant blood proteins, inherited traits that allowed their species to dominate sub-zero climates for millennia. Researchers were moved by how well the emotional narrative matched the scientific evidence. The mother's body showed stress fractures in the ribs and hip, likely caused by struggling to free herself from frozen mud. The calf's lungs were partially inflated, implying it suffocated shortly after the mother's fall. The evidence pointed to a single catastrophic event, a sudden, unstoppable flood that buried both in ice within hours. The Pleistocene steppe elephant remains. Paleontologists found something huge in 2022 while digging in an old wetland near Kostyonki in western Russia. This is a famous place for finding Ice Age objects, the tip of a tusk stuck out of the packed glacial clay. It was yellowed from age, but it was still clearly very big. The head and some of the body of an extinct Pleistocene steppe elephant were carefully taken away over the course of weeks. This giant animal ruled Eurasia long before the woolly mammoth showed up. So well were the animal's bones kept that pieces of its trunk and mummified skin were found frozen in soil, giving scientists a rare look at a species that went extinct more than 400,000 years ago. The steppe elephant, Palaeoloxodon antiquus, was one of the largest land mammals ever to walk the earth. Adults stood up to 4.5 meters tall and could weigh as much as 14 tons, far larger than the later woolly mammoth. Unlike its hairy descendants, it had smoother skin, long limbs, and massive tusks that curved forward in a gentle spiral, some exceeding 5 meters in length. This particular specimen, found in near pristine condition, helped scientists bridge the evolutionary gap between warm climate elephants of the Mediterranean and the cold-adapted mammoths of the north. The remains were discovered inside a layer of perennially frozen soil, an ancient river delta that had been periodically flooded and refrozen through multiple ice age cycles. The elephant's bones were found in anatomical order, suggesting the carcass hadn't been disturbed by scavengers. Even more remarkable, the excavation revealed fragments of dried trunk tissue still clinging to the skull's nasal cavity. When analysed, these tissues showed well-preserved collagen fibres and microscopic skin cells, the first direct evidence of how steppe elephant trunks were structured. The discovery allowed scientists to confirm that these giants had flexible, muscular trunks similar to modern elephants, capable of fine manipulation rather than just heavy lifting. CT scans of the preserved skull revealed a sinus system and brain cavity adapted for colder environments, hinting that this population was already evolving toward woolly mammoth-like cold tolerance. The tusks contained distinct growth rings, like tree trunks, which recorded decades of the animal's life. By analysing oxygen isotopes within these rings, researchers could reconstruct the climate of each year the elephant lived. The data showed alternating warm and cold periods, reflecting the unpredictable glacial cycles of the mid-Pleistocene. During colder intervals, the elephant's diet shifted from forest plants to tundra grasses, suggesting an adaptable feeding strategy that may have helped it survive in changing environments. One of the most astounding things that was found was by looking at the residue in the animal's teeth under a microscope. In the teeth, there were pieces of old pollen and silica from plants that helped scientists figure out what it had for dinner. At least 7 types of plants were found in these samples, such as field grasses, willow leaves, and sedges. This showed that the elephant had been eating on a river plain before it died. These clues, along with sediment research, suggested that it may have been caught in a sudden mudslide or flash flood, buried quickly, and frozen under ice and silt. The surrounding area yielded stone tools and butcher marks on nearby animal bones, indicating that early humans, likely Homo heidelbergensis or an early Neanderthal population, inhabited the same landscape. Though no cut marks were found directly on the elephant's remains, it's possible that early hunters encountered the carcass after it froze and scavenged ivory or meat. This makes the steppe elephant one of the earliest direct links between prehistoric humans and the megafauna that shaped their survival. Preserved hair fragments found in the surrounding clay were another surprise. While woolly mammoths are famous for their thick fur, the steppe elephant's hair was sparse and short, about 2 centimeters long, adapted for a temperate rather than icy climate. However, traces of sebaceous oil and fatty acids found in the skin samples indicated natural waterproofing, allowing these giants to wade through rivers and wetlands without losing body heat. It was a sophisticated adaptation that likely helped them survive the harsh transitional climates of Eurasia. The specimen, now preserved at the Russian Academy of Sciences in Moscow, stands as one of the most complete steppe elephant finds ever recorded. The skull alone measures nearly 2 meters from crown to base, and its tusks arch outward like polished ivory crescents. Scientists have reconstructed the animal digitally, revealing a creature both familiar and alien. The bridge between an elephant and a mammoth, warm earth and frozen steppe. Hunters in northern Yakutia were looking for mammoth tusks in the plains along the Indigirka River in 2021. They came across a field of antlers sticking out of the thawing permafrost. At first, they thought it was just one skeleton. What they really found, though, was dozens of bodies of reindeer that were all mixed up with each other and their horns still locked together in battle. When they were lying next to each other, they seemed to be frozen in the middle of a fight, like time had stopped. When experts got to the site to study it, they saw something that seemed almost impossible: an entire herd of Ice Age reindeer frozen in ice, where they had been since a storm more than 45,000 years ago. The discovery site was a frozen floodplain, where seasonal meltwater from ancient glaciers once pooled each summer before refreezing. The layer containing the reindeer was sealed beneath more than 2 meters of solid permafrost. When the ice was carefully cut away, paleontologists from the Mammoth Museum of Yakutsk uncovered over 30 individuals, males, females and juveniles, preserved in lifelike positions. The adults had enormous sweeping antlers, some still tangled with each other. Their fur was thick and reddish-brown, and in several specimens, the skin, muscles and internal organs were still intact. The animals belonged to an extinct subspecies known as the Pleistocene reindeer, Rangifer tarandus palaeolatus, larger and more heavily built than their modern descendants. These reindeer stood up to 1.5 meters tall at the shoulder and carried antlers nearly twice the span of modern caribou. The herd had likely been migrating across a frozen valley when catastrophe struck. Sediment analysis revealed rippled layers of frozen silt, suggesting a sudden mud and ice slide, likely triggered by a violent snowstorm or rapid melt. Within minutes, the ground beneath the herd collapsed into slush, swallowing them whole before refreezing solid. When researchers thawed several of the carcasses in controlled conditions, they found details so precise that even fur coloration patterns and whiskers were preserved. The hooves still bore faint wear marks from long-distance travel, and one female still carried an unborn calf, the first pregnant reindeer ever found in permafrost. Radiocarbon dating placed her at roughly 46,000 years old. Inside her preserved womb, embryonic tissue was still visible under a microscope, offering an unprecedented look at Ice Age mammalian reproduction. The antlers told an equally fascinating story. In many males, the racks were still locked together in pairs, evidence of combat behavior similar to modern reindeer during the rutting season. Some antlers were snapped or gouged, others twisted and fused with ice. This led researchers to propose a dramatic final scene. During a seasonal battle for dominance, a group of males became entangled and fell into a mud pit, dragging others with them. The mix of combat and migration chaos likely turned into a stampede, ending when a blizzard froze the entire group within hours. Chemical analysis of the reindeer's bones revealed alternating seasonal patterns in oxygen and nitrogen isotopes, a record of diet changes throughout the year. The animals had fed on tundra mosses, lichens, and dwarf willow twigs, consistent with steppe habitats just south of the glacial front. The data also showed that the herd endured cycles of scarcity and abundance, lean winters followed by lush summers, typical of Ice Age ecology. In the end, it was likely one of those unstable spring thaws that claimed them. Under electron microscopy, the reindeer's hair displayed remarkable preservation. Each strand contained hollow air-filled cores, an adaptation for insulation still present in modern Arctic species. This structural feature confirmed that Ice Age reindeer were already fully cold-adapted long before the last glacial maximum. The presence of thick underfur, still attached to the hide, proved that their coats could withstand temperatures as low as -50 degrees Celsius. Their anatomy, short tails, compact legs, and broad hooves match perfectly with life on frozen tundra, allowing them to walk atop snow and dig for hidden vegetation beneath ice crusts. One of the most unsettling finds was in the ice layer below the herd, weak hoof prints that were still perfectly clear in the frozen mud. These prints, which are close together and repeat, show the last steps of animals that were trying to stay upright as the ground gave way. It was a terrifying moment that was stuck in time, like a film of the herd's last seconds. In 2022, scientists extracted DNA samples from several of the frozen reindeer. The genetic material was remarkably intact and revealed that these Ice Age herds were direct ancestors of modern Eurasian reindeer populations. They carried the same genetic markers for cold resistance, fat metabolism, and seasonal coat shedding. However, their larger body size and thicker bone density suggested they lived in colder, windier environments than reindeer face today. The DNA also showed extremely low diversity, implying that their population was already under stress from changing climates, a precursor to extinction. The ancient cave bear frozen beneath Arctic glaciers. In 2020, reindeer herders walking across the Liakovsky Islands in the far north of Siberia made a finding that scientists were shocked by. The body of an adult cave bear came out of the melting permafrost in perfect condition, with all of its fur, skin, claws, and teeth still in place. Earlier finds only included heads or parts of bodies. This one, on the other hand, was a whole animal, an Ice Age animal that was lying exactly where it had fallen almost 40,000 years ago. It was the first full cave bear ever found in history. You could see its nose, paws, and even its internal parts. The discovery site lay in a remote Arctic region where thawing permafrost continues to reveal astonishing Ice Age remains. When the herders first noticed what looked like the head of a bear protruding from the ice, they assumed it was modern. But as melting progressed, the truth became clear. This animal was prehistoric. Scientists from the Northeastern Federal University of Yakutsk were immediately dispatched by helicopter to investigate. When they arrived, they found the bear lying curled in a shallow depression, its massive forelimbs folded across its chest, as if it had simply fallen asleep in the snow. Radiocarbon dating placed the bear at between 39,500 and 40,000 years old during the late Pleistocene, a period when Siberia teemed with woolly mammoths, lions, and reindeer. It belonged to Ursus spelaeus, the cave bear, a species once common across Europe and northern Asia. These bears were much larger than any living species today. Males could weigh over a ton, with shoulders as tall as a man's chest, and long domed skulls adapted for powerful jaw muscles. Despite their size, isotopic studies suggest cave bears were largely herbivorous, surviving on a diet of roots, berries, and tough mountain plants. The preservation of this specimen was nothing short of miraculous. Its fur, thick, golden brown, and coarse, still clung to much of the body. The nose, rarely preserved in Ice Age fossils, was completely intact, giving scientists a chance to study its breathing structures and scent glands. The bear's teeth were in perfect condition, showing the flat grinding surfaces typical of plant-eating bears. Even its claws remained sharp, each one encased in blackened keratin that had survived 4 ice ages. Dissection under laboratory conditions revealed that many internal organs were also preserved, including the liver, kidneys, and lungs. Samples taken from the chest cavity still contained traces of hemoglobin, the same oxygen-carrying molecule found in modern blood. Muscle fibers and fat tissue were identifiable, and microscopic analysis showed intact cell membranes, an almost impossible degree of preservation for something so old. The permafrost, acting as nature's freezer, had essentially paused decay from the moment of death. No one knows how the bear died. The most popular idea is that it died while hibernating. The way it was lying, curled up with its head sitting on its folded paws, and the type of soil around its body suggest that it may have been caught when its den collapsed in snow or ice. The body would have been shut off before scavengers could get to it because it was buried quickly and frozen. Similar deaths during hibernation have been seen in smaller Arctic animals that live close, which supports the theory. DNA extraction done in 2021 led to one of the most important science discoveries. A genetic study of the bear's bone marrow proved that it belonged to a northern group of cave bears that used to live from the Ural Mountains to eastern Siberia. Researchers were able to map large parts of the cave bear genome because the DNA was so well preserved. When compared to current brown and polar bears, they showed many surprising similarities as well as important differences. Because cave bears didn't have certain genes for fat metabolism, they might not have been able to adapt to the warmer temperatures that came after the Ice Age. They probably went extinct about 24,000 years ago because they couldn't adapt. From mammoths still covered in fur to cave bears that look ready to wake, every creature pulled from the ice reminds us that extinction doesn't erase, it only pauses. These frozen giants are messages from the past, showing us how fragile life was when the world stood still under endless winter. As the glaciers melt, more secrets will rise to the surface, but for every discovery, another piece of ancient history disappears forever. If this journey through Earth's frozen tombs amazed you, leave a like, share your thoughts in the comments, and subscribe for more incredible stories of the world's lost creatures before the ice and their memories vanish for good.